This next example uses something called a cardioid. Somebody who teaches this class and knows geometry would be able to pronounce that word for you. I cannot. So we're going to call it a cardioid, unless somebody wants to ask Wikipedia how to pronounce it. And we're finding the integral of 1 over x over the region D. And D is the region that lies inside. That's not how you spell inside at all. Inside the circle r equal 3 cosine theta, and inside the cardioid I wrote it extra neat so you can Google that word if you're curious about it. R equal 1 plus cosine theta. And a picture of this, here's x and y. The circle r equal 3 cosine theta is okay. So it's going to be centered at 1.5, I guess, here, and then it'll have a radius that I sure hope we don't have to find, because it's 1.5 squared. So we'll go ahead and just draw it and figure it out later. So here to find out where that circle was, I just used like backwards the same trick we've used a bunch of times so far, where like we know that y squared plus x squared, and an off-center circle becomes r equal 2 cosine theta or r equals 2 sine theta, depending on where the center was. So that's just what I did there. And then the cardioid, just have to accept that it is something that looks like this. Kind of like a really floppy heart. And that's not that I'm bad at drawing hearts, it's that it really looks like that. Okay, so this is the circle, 3 cosine theta, and this is the cardioid, 1 plus cosine theta. And we want to be inside the circle and outside. First part I did here was wrong. Outside the cardioid. So we want to be in this region right here. Inside the circle, outside the cardioid. Okay. So I have no idea how I would write this in Cartesian coordinates, and they gave me my bounds in terms of r's and thetas, so I know that I should be converting it to a polar problem. So my dA becomes r dr d theta, and my 1 over x becomes 1 over r cosine theta. And then I just have to fill in my bounds. So it was really helpful. They said we're inside this circle and outside this cardioid. So the closest we ever are to the origin is right before we start cutting out the circle. So it's this one. Closest distance is 1 plus cosine theta. And the furthest distance is after we've entered the region, we go out until we hit the circle. So they gave that to us as 3 cosine theta. So our first bounds for r can just come from what was given in the problem. But personally, it's really hard for me to tell where my thetas are. So I can kind of like draw and say I have to go this far back and this far forward. So I think that I'll have a negative value here and a positive value here. But that's about all I can figure out just from looking at the picture. So then I'm going to go back to how we dealt with this problem for like regular double integrals. And it was when I know that I have two curves intersecting, I set those curves equal to each other and solve for my value. So when these two curves touch, it's when the distance r on the inside curve, the cardioid, matches the r on the outside curve, the circle. So my bounds for theta are when my radius r equal to 3 cosine theta matches my radius r equal to 1 plus cosine theta. So that means that 2 cosine theta is equal to 1, just subtracting cosine theta from both sides. Cosine theta is equal to a half. And then I would have to like look at a circle. Sorry, like a unit circle, not just any circle, to find out that when I want half, I have to go plus minus pi over 3. That'll give me my 1/2 in my x direction. And something with roots on the other one. Sorry, you all know what I'm talking about here. It's like it's a circle and it has a bunch of points, and you know that for the x coordinate, it's the cosine, the y coordinate, it's the sine, and that's how you figure out the right angle theta to use. Just remember like the handful of values that you need, the pi over 3, pi over 4, etc. So to solve this equation, I need theta equals plus minus pi over 3. So the minus is when I spin clockwise, so the furthest from counterclockwise I ever am, negative pi over 3. And then the positive one is my distance I swing back counterclockwise. My upper bound, positive pi over 3. And let's see how we are on time. I'm going to start doing this, and then I'll just cut it out, I guess, if I have to. So this integral is from minus pi over 3 to pi over 3, from 1 plus cosine theta to 3 cosine theta. 1 over r times r canceled out, so it's just 1 over cosine theta dr d theta. So integrating with respect to r first just gives me integrating dr is r, evaluated from 1 plus cosine theta to 3 cosine theta. And then the 1 over cosine theta may as well be a constant to me. So I get 3 cosine theta minus 1 plus cosine theta. And I'm evaluating that from negative pi over 3 to pi over 3 times 1 over cosine theta d theta. This is 3 minus 1 is 2 cosine theta minus 1 over cosine theta d theta. Yeah, I'm not doing that.